Welcome to our FEDSA mentoring sessions, everybody. Today, we've actually got a special guest, Justin Slack, who's, I believe, from NML, and he's been in web development design for a super long time. And we're actually very lucky to have him here today to sort of show us about web typography. And I'd just like to mention that our sessions are sponsored by Code Capsules, which is a platform as a service. You can post your websites, basically any sort of medium, as far as I know, you can actually host it through them. And for South Africans, the websites are incredibly fast. I've never seen a site load as fast as that when you're hosting on their platform. So definitely give them, have a look at their services.
Okay, thanks, Martin. Just to introduce myself, as Martin said, my name's Justin. I'm head of design at a company called NML. We build design and build software applications. I have been designing and building for the web for a long time, over 2 decades. And along the way, I've learned a little bit about typography. So that's what I want to share with you today. And then we have another session next week as well. So the session today is largely going to be an introduction, and we're going to look at some typographic concepts. There we go. And we'll look at fonts in the browser. And then next week, we'll get into the nitty-gritty of the kinds of CSS properties we have to influence type. And we'll look at how we can best present our type for readability and legibility. So whenever I talk about typography, I start with this quote from Oliver Reichenstein, who's founder of a company called Information Architects. They do a lot of design work based in Japan, and they do a lot of work for newspaper type news organizations, where the primary form is, of course, reading. And he wrote this in 2006, an article called Web Design is 95% typography. And to some extent, this is absolutely true. We think about what we're doing online most of the time is we are reading, and we need to structure that reading experience as best as we can for our users. Right, so let's start right at the beginning with a rather thorny topic, and that is choosing a typeface. And, how do you go about doing this? Now, often you might say, well, that's not the job of a developer, right? It's the job of a designer. But once we start to work in front-end development, and we are laying out and building websites that contain type and text, we are essentially being typographers ourselves. So we may not have any specific training in design. We certainly aren't building and creating and designing typefaces themselves. We still have a large influence over how this happens. So choosing a typeface isn't necessarily purely the domain of the designer. There are a number of things that we need to take into consideration when working with type, and within that fundamental thing of choosing a typeface. So I'm going to run through some kind of theoretical concepts, I guess we could call them, around typography. And these are important to know because they influence the way in which we end up building our sites and applications. Now, this is not the terminology and history and everything to do with typography is a massive, massive subject. I mean, we've had printed items since the 16th century, going all the way back to Gutenberg. Before that, we had handwritten artifacts and books, particularly monks who would transcribe the Bible. We have writing systems from ancient Egypt, from China, from Asia, and so on. The digital type is a new thing. In digital type, and particularly in Western languages and languages that use particularly what we call the Latin alphabet, which is the one we are familiar with mostly, we have a number of font categories. I'm just going to run through a couple of these because it's important to know what we are talking about when we are talking about fonts. And this also has some impact on how we write our code, because our font categories are something that appears within CSS itself. So we have 4 basic font categories that I'm going to mention. There are others, but they aren't relevant for the screen. They are relevant for type. So the first one is a serif, and you may be familiar with these terms. If you've ever written any CSS and you've declared a font family, you've probably declared something as a serif or a sans serif. And you may have also encountered a monospace font when looking at blocks of code, particularly if you know, when you're opening up your Visual Studio code and you're looking at the code that you're writing, that is always being rendered in a monospace font. And a monospace simply means that all the letters are the same width, hence the term mono one. And then the other typeface that you may have encountered in the past is script, and this emulates handwriting. We're really just going to concentrate on 2 of these categories at the moment, and that is serif and sans serif. So a serif font is distinguished quite simply by the fact that it has feet or non-structural details at the end of some of the strokes. Some people refer to these as flourishes, and we look at an example of a serif font. In this case, we're looking at Merriweather, and you can see on the T that starts there are those 2 downstrokes at the top. There's a bar at the bottom, and if you look at all the other letters, you'll see similar things that are attached to them. So feet or non-structural details. Non-structural meaning the meaning of the letter is not changed in any way by these additional details. The definition of a sans serif font is literally the opposite. It literally means without feet. Okay. And an example of that would be something like Avenir. And you can see here we have the same word typography, but we don't have those additional flourishes. We don't have any feet. We just have straight lines. So sans serif typefaces will have less stroke width variation. So they're generally a lot thinner. And you'll see the width on these elements within the sans serif font are uniform. They're all the same. If you look at the lines that make up the Y, for example, you can see the width on those is all the same. In a sans serif font, we tend to find that those are different, and there's a lot of differences within the stroke widths. Sans serif fonts tend to be used to convey simplicity or minimalism as well, and they've become the most prevalent ones for display on text on computer screens. The reason for this really goes back to the beginnings of type on the web, and on lower resolution digital displays, which we had back then, fine details in serifs often disappeared, or the opposite, they looked, in fact, too large. So we've definitely had a move towards sans serif over the last few years. If you go onto Google Fonts, for example, and have a look around there, you'll see the sans serif fonts vastly outnumber the serifs. This doesn't mean we should never use a serif font on the screen. It just means we need to weigh up something that we can call function and form, as is, what is the relationship between letters and their content? I'm going to get into this in more detail next week after we've gone through this whole introduction, where we can look a bit closer at how function and form influences reading and that particular relationship between our letters and our content. Basically, the question we need to ask with function and form is, what is the font being used to display? If we're displaying small body text, a sans serif font is going to be less readable than a serif font. If we're displaying big headlines, we may want to start looking, in that case, at a serif font, because we have a lot more structure to those letters. So those questions we can ask, and as I say, we'll get into that into more detail next week. So let's look at the basic anatomy of a typeface. In this case, I've got a typeface from Google Fonts called Carla, one I use quite a lot. And here the word I've written out is hand glovery, which is a meaningless term, but is something that typographers use because it gives a good overview of basic letter forms within a font. So you've got a large range of different forms that you can then look at within this particular word. Now there are over 50 terms that respond just to certain parts of an element or a letter. And I'm not going to go through those because that will keep us here for the rest of the session. I'm just going to go through a couple that are very useful for us when we're looking at type on the screen. So the first one we're looking at is what we call a terminal. Okay, and the terminal is that part there in our letter, on our letter where a curve ends. Okay, so anywhere where a curve ends, we have a terminal. So on our A, we can see that the ending of the curve of our A is a terminal. If you think what does the word terminal mean, it means an ending. Right? So we have an ending there on our letter form. Another important one we need to know is what's called an ascender. An ascender refers to wherever a letter goes above the normal flow of the letters. So in this case, our D and our L, in this case, are taller than our A and D, our A, our N, our O, our B, etc. And that is called an ascender. Anything that goes above something is the ascender. We have another terminal here as well in our word, and that is on our R. You can see there we've got another curve, and we've got an ending on that curve. So that is a terminal. Now, the reason why I'm introducing these is because they play quite a large role when selecting type in terms of their readability. And again, that's something I'll go into more detail next week. We just need to start getting familiar with these terms. So just as we have an A sender, we also have a D sender. And you can see the D sender on the Y there. That goes underneath or at the bottom of the height of all our other letters. And then we have what is called a loop, and that is generally on a letter like a G. And that is where we have a closed element underneath the letter. So a descender will always be open, as we can see on the Y. It's an open shape, whereas the loop is a closed shape. And then finally, we have what we call counters, and counters are within a letter. So we see on our O, we have a shape inside that, and that is what we call a counter. And we have that as, again, on our E, another counter, and on our A, we have another counter. That is wherever we have a closed item. Technically, we also have one on our G at the bottom of that loop. You know, I didn't add that because I didn't want to complicate how we displayed that. So these are the type terms that we need to get familiar with. Terminals, how do we end a curve? Ascenders, what is above the height of the other letters. Descenders, what is below. A loop, where we have a closed element at the bottom, and then a counter, which refers to the shape inside particular letters. Okay, the reason these are important is that they all combine to form readability and legibility for different typefaces. Okay, so I'm going to just pull up a number of instances of the letter A, all done in different typefaces. So first off, we have Gotham Ultra. As you can see, that's a really, really extremely bold font, hence the name Ultra. Then we have another version of Gotham, so from the same family, but this is Gotham Book, which we might refer to in CSS as normal. We then have Baskerville. So our first two are sans serif, and our next one is serif. We then have Bodoni Old Style, which again is a serif font. We have SF Pro Text, which is the Mac and all Apple devices default font. And then we have Lucida Grand, which is a sans serif font, but as you can see, has a little bit of a flourish there. Okay, now the reason why I'm doing this is because these are all the same size. They're all the same size in pixels or points or however you want to measure them. As you can see, different typefaces have different heights. And this greatly influences, again, how we design things for the screen and on the web. So if you go back and we think about our counters and our terminals, you can see that they're very different across these typefaces. If we look at our first two, which is Gotham, you'll see that terminal is at a slant, and that we refer to as an open terminal. The same for Lucidagram to some extent. But if we look at the second last one, SF Pro Text, you'll see that that terminal is at 180 degrees. And that is what we call a closed terminal. And if you look at the second Gotham in book format and Lucidagram, and you compare them to that SF Pro Text, you can see the way the terminals are structured makes them far more open. And there's a lot more white space in the actual letter form. And that's generally as a rule of thumb. But as I say, as a rule of thumb, it's not always the case, makes for a more readable typeface, particularly at smaller sizes. So our font with old style figures, that's the two sans serifs in the middle. You can see there that we've got quite a closed typeface there. Okay, there's not a lot of space. But if we look at the counters, and remember that's the space inside, we can see that with the exception of Gotham Ultra, because that is obviously extremely bold and meant for massive sizes, the rest of them have very open counters, and that makes them a lot more readable. Right, so if we've got consistency across our typefaces, we should be looking at creating kind of an even texture in a block of text. Right, so here's something to demonstrate this again, and this is just using another letter with the same fonts, and that is the letter Q. And here we're looking at, let's ignore our terminals, etc., and let's look at our descenders. Again, these are the same size. They are sized exactly the same. And you can see that our descenders are completely different across the board. So our sans serifs are quite similar, but still different heights. But our serifs are a lot longer on our descenders. Yet the height of the serif font itself is a lot shorter. So we can see that in a serif font, we tend to have descenders that take up a much larger proportion of the actual letter form than they do on sans serif fonts. Right, so if we have very long descenders and we have multiple lines, we tend to get quite jumbled text, particularly in something like a headline. So that's again something we really need to take into account. How are our descenders affecting the way our type looks? Okay. Right, so I've talked about height of our typefaces, and this is just to introduce another concept, term that's very, very important when we're looking at type, and that is what's called xheight. So xheight refers to the height of a lowercase x. And this height should be seen as a relative unit for measuring the proportion of lowercase letters. So when we say the x height of the font, we mean the height of a lowercase x. I've got the same typefaces here. And as we go through them, you'll see how I've used the x height of the Gotham Ultra at the beginning. You'll see how the x height is going to change. So very similar between Lucidagram and SF Pro Text as the last two, but you can see quite a bit of variation between Gotham Book and Baskerville and Botanic Old Style. So x height refers to the height of a font. If a font has a small x height, it's going to be much smaller at, say, 16 pixels than a font with a large x height. Again, these are all rendered at exactly the same point size. So even though I'm making them the same size, the typefaces themselves have different heights. And this is something we need to be very, very cognizant of when selecting typefaces. So let's look at taxidermy as a word chosen because it has an X. And our first typeface here is SF Pro Text. As I said, the default font on Mac device, on Apple devices. And we can see on our xheight there, and then now where I've drawn those two dotted lines. Now look specifically at the ascenders and the descenders, and you can see there is not much of a difference between those two. Right? So the ascenders and the descenders average the proportion of the typeface are quite small, whereas the xheight is quite high in proportion to the rest of the typeface. If we look at basketball, we can see something different. First of all, the xheight on basketball is a lot lower than the xheight on SF Pro Text. Again, these are the same size. Yeah. But if you look at the ascenders and the descenders on basketball, you can see their proportion to the xheight is much, much higher. And here we can see them next to each other, and I've just shortened the word and made it taxi. So you can see that despite being the same size, the xheight is completely different. But if you look at the I, the dot above the I on our basketball, the second font, you can see it's not much lower than the I on SF Pro Text. So two completely different typefaces, two completely different xheights. But to some extent, once we bring in ascenders and descenders, they start to more or less be the same height overall. Okay, so there's a thinking that typefaces of tall xheights, i.e. SF Pro Text, have a better legibility at small font sizes because there's more white space within each letter. But, you know, as with all these things, that isn't always the case. Okay, so, you know, which is better? And, you know, my answer to this is going to be, who knows? It depends. So we do sometimes tend to think that tall xheights have better legibility at small font sizes. And that is a rule of thumb. But as I say, a rule of thumb. Sometimes it applies, but other times it doesn't. Right. So let's look at two typefaces that we see all the time. Now, at first glance, those might look the same, but they are not. On the left, we have Ariel. No, so this is incorrect. On the right, on the left, we have Helvetica, and on the right, we have Ariel. Okay, so Ariel was developed by Microsoft for the screen, and to some extent, it is very, very similar to Ariel. But you can see, if we look at these closely, we can see in our terminals that Helvetica is very closed off, while Ariel is actually very open. And for as much hate as Ariel gets, to my mind, it is a better font for the screen than Helvetica, which was developed in the 1950s, and primarily for print, not for the screen. So if we look at these two, we can see quite clearly that the ones on the right are more readable than the ones on the left. And that's largely because of that terminal that is not closed off. It's not 180 degrees. It's far more open, creates more white space and opens it up. So what we really want to be doing is looking for type that is clear and recognizable. And for that, we should be looking at each letter should have a distinctive shape. How many times have you typed the word ill and it looks like, with a capital I, and it looks like 3 straight lines? That's not a very clear and recognizable typeface. So each letter should have a distinctive shape. We want open forms, as I've mentioned. We want clear terminals, and we want some kind of contrast between our letter forms. So next week, I'll speak about this in more detail, and we'll look at examples, and we will write some CSS to see how we can make things clear and recognizable. The other question that often comes up with typefaces is, you know, should you use one? Should you use more? as a designer, I can say this, designers are very type happy and tends to go maximal rather than minimal. But once we translate things to the web and to the screen and to managing code bases and front ends, we need to think very, very carefully how we work with the number of typefaces. And most of the time, I think we can get away with one family and have variants. So in other words, choose one family and then choose a number of variants of that, like a bold, a medium, and a light. For example, we really don't often need more than one typeface. Sometimes, as projects grow and we start to introduce more functionality and different aspects, and the UI becomes complex, we might need to have a typographic response to that. But if you're building a website, if you're building a small application, you don't really need more than one typeface. You can easily get away with that. But yes, as I say, sometimes we need a typographic response to complexity from a design point of view. Okay, so the other thing we need to think about are glyphs. So when we use the term glyph, what we are doing is we're referring to every letter form that is contained in that typeface. And that is letters, both lower and uppercase, alternate styles of letters, different language support for those letters, but we're also talking about numbers, and we're talking about punctuation forms. So do we have all these required glyphs, and are those correctly designed? And do we have correctly designed diacritic marks? So diacritic marks just referring to punctuation. Sometimes you'll find that typefaces don't have a full glyph set. And this has hurt me in the past, where I used a Google font and it didn't have a version of C with a particular accent, and rendered that as the default fallback typeface and looked really, really terrible. Right, so we need to check that. And do we have open type features? Now I'm going to talk about open type features in more detail next week, but open type features, just on a simple level, are additional features we have in a typeface that allow us to do things like accents and fractions and small caps and so on. So that will become a little bit clearer next week when we look at that and examples and how to use them in the browser. Right, so just to illustrate this example of missing glyphs in the typeface. So if we look at the word facade, we can see there that the C has to be honest, I don't know the technical term for this. And I have not looked it up, so apologies for that. But you can see the C has an additional element to it to indicate its pronunciation. And this is a French to French word. That we now use in English, that we have borrowed from French. Now, let's say your typeface is missing that particular glyph for this language variation. What it's going to do is it's going to fall back to the browser default. So in this case, we're using a sans serif font. The font that is rendering this here is Quicksand, but let's say, and Quicksand does have this, but let's say it didn't. What you would then do on a Mac, for example, is that C that we need there to make facade would fall back to the default font, which is SF Text Pro. And that is completely different in terms of how it renders that glyph. So you can see there we now have our FAADE rendered in Quicksand as we want it, but our C is now being rendered by SF Text Pro. And it's not doing a good job in the sense that our typography is now broken. We no longer have that consistency that we need. So checking that typefaces have all the required glyphs is really, really important. And there are tools for that, and we'll look at them next week. Worst case scenario is this glyph is not supported by your typeface, and it's also not supported by the fallback typeface. And in that case, you get the Unicode not found, which is basically a blank box. again rendering our type even less readable. Okay, so that covers the kind of terminology that we need to know and the things we should be thinking about when we are going to be choosing typefaces, but also when we're going to be enabling custom fonts in our websites and applications. So next up, I want to talk about fonts in the browser, where they come from and how we get them there. And this has been a long and arduous thing to happen, and it still has major, major problems, despite it being, 2021, and we've been using custom fonts for a long time. There are still many, many problems with them. So let's go all the way back to the 1990s, when the internet became a public good and anyone could publish their websites. We had very few options for fonts on the web. So one of the things that needed to happen was for browsers and operating systems and so on to render type and fonts was the invention of digital type. And while digital type had predated the PC or operating systems by many decades, they didn't live within what we would now call our operating systems as we know them. And the first time digital type was available to the public at large was in 1983, when Apple released the Lisa computer, which was the first one with a graphical user interface designed for home use. So when we think about the history of typography going back millennia, and we think about digital type, we're talking about decades. So there hasn't been a long time that digital type has been with us. And previously, prior to 1983 and the release of graphical user interfaces, there was research in digital type, but it had been very print-centric. Okay, so it had been around things like PostScript and rendering type on the screen for print rather than for viewing on a screen. So the Mac Lisa, as I said, released in 1983. The typefaces and fonts were all designed by a designer called Susan Kerr, who did what was at Apple for a long, long time doing designs. And these are the ones that were available. And if you look at them, you'll notice that they are all very pixelated. Right? The reason for this is that these original fonts were all bitmaps. We don't have bitmap fonts anymore. That was the reason that they're pixelated like that. Yeah, so those were when you got your Mac Lisa in 1983 and you opened up your graphical user interface, you were given the choice of these particular fonts. Now, Monaco and Geneva still exist in new forms. The others not so much. And Apple has resurrected San Francisco and now calling it SF text as its operating system. So that was graphical user interfaces on the Mac and the PC at home. With the advent of the web, we suddenly got text in the browser. And this is a screenshot of the very first website created by Tim Berners-Lee in 1993. Was it 1991? I'm not sure. It was the very early 90s. And you'll see it just consists of text. But we have a few things that we can say when we look at this text. First thing is that the text is sans serif, and it's Times New Roman. We have some hierarchy to the typography. That is, we have a heading at the top that is in bold, and then we have text that is in what we would call normal, but in type terms is regular or book. And then you'll see we have links that are blue and underlined. And these are the defaults we still get with the browser when we do typography in 2021. If we go to our VS Code and we go and put in some HTML and we have an H1 tag and some paragraphs and some links, and we have no styles, no CSS whatsoever, and we open it in the browser. This is essentially what we will get. So that hasn't changed since then. We now, of course, have ways to deal with this and to make changes to it. But for a very, very long time, online, you couldn't make any changes to how your type looked. And certainly CSS was a long, long way away with the first browser only supporting full CSS text properties in the year 2000, which funnily enough was Internet Explorer 5 for the Mac. Also the last version of Internet Explorer for the Mac that existed. Right, so in the 90s, Microsoft decided, okay, everyone is going to be doing things on the screen. We need to start developing fonts and typefaces that work on the web. And Microsoft started this initiative called Core Fonts for the Web in 1996. And this led to a number of typefaces I'm sure you are very, very familiar with, namely Ariel, Georgia, Badana, Comic Sans, and two I can't remember offhand. There were 6 typefaces that Microsoft developed, particularly for the web. So they were designed to be used on the screen, and it was the first time that it happened. Prior to that, everything had been designed to be used for print. So this initiative of Microsoft kickstarted a whole new development in typography of designing typefaces to be read on a screen. Okay, and at the same time as this was happening, we had the development and the very, very slow adoption of CSS. And these two things coming together started to allow us to do a lot more with type than we previously had been able to do. And this also coincided with something rather dramatically called the font wars. And this was around typographic formats. And it was largely between the 3 big players of the time in typography, which was Apple, Microsoft, and Adobe. And there was a lot of weird things that happened. Apple proposed something called Apple Advanced Typography. Adobe proposed something called Type 1, which came to be known as PostScript. Then, in a weird turn of events, Microsoft and Apple got together and proposed something called TrueType. And then, in another weird turn of events, Adobe and Microsoft got together and proposed OpenType. Now, you may recall that a little bit earlier, I mentioned something called OpenType features. And the reason for that is that OpenType has become the font format. So all of these kind of jostled for uptake, and eventually it was OpenType that won out over all the others. So nowadays, whenever we open, we might see TrueType and we might see OpenType fonts. If you download a font and its extension is TTF, that means it's a TrueType font. If you download a font and its extension is OTF, it means it's an OpenType font. I'll go through the differences between those next week, but it's important to know this because OpenType gives us a lot more than TrueType. So again, when we're looking for fonts that we want to use, OpenType is going to give us a lot more than TrueType. Okay, so we had Microsoft working on all these things, all these different typefaces. We had people contesting different formats, and we had the slow development of CSS. And this all brought us to where we are now, which is, fonts in the browser. And if you go to Google Fonts, you'll see there are now 952 font families just on Google Fonts alone that we can choose. So fonts in the browser are all made possible by a CS property called @Fontface. I've always found it a jarring name, but so there we are. Face, a contraction of typeface. And this allows us to have custom fonts. Now, this isn't a new thing. The first browser to support custom fonts was Netscape Navigator 4 in 1994, but they used a proprietary technology called Bitstream, and you had to do some really nasty stuff. There was no CSS, so you had to wrap your HTML in font tags and have tons of attributes. And then you had to run a special plugin to make them work. And yeah, it was nightmarish. Netscape would become Firefox. So if you use Firefox nowadays, that was born out of the Netscape browser. And then Internet Explorer. Everyone hates on Internet Explorer, but IE has actually supported Fontface as we use it today since 1997. It's the very, very first browser to implement it as something that could be used in the browser. And as proof, an article from Browser News in 1997 saying that we now have embedded fonts in Microsoft Internet Explorer 4. So that's been around forever in IE. And back then for IE, we would use the syntax very, very much the same way that we do now. The only difference being, you might notice that EOT is a format that you've never heard of. And that stood for Embedded Open Type. And it was a proprietary Microsoft technology. So you could have custom fonts, but they would only work in Internet Explorer. If you went to a site in any other browser, at the time there was really only Netscape, you just wouldn't see that font. You'd have to run a special ActiveX Java applet plugin, things that have gone the way of the dinosaurs, fortunately, and then refresh the page in order to see the type. So, no one really bothered with it because it wasn't worth the effort. But the syntax, as created by Microsoft way back then in the mid to late 1990s, is the same one we use today. So all of these formats for the web were superseded by WOF, or the Web Open Font format. And this took open type fonts and compressed them significantly and allowed them to be displayed on the screen, and also let the type foundries stop worrying about copyright on their typefaces, because WOF cannot be read anywhere except the browser. So this was developed by Mozilla Firefox, a browser maker, in 2009, and it was adopted by the W3C as a standard in 2012. And in 2015, WOF 2 was introduced, which led to another 30% reduction in file size. So we're taking large font files and we're compressing them quite significantly using compression algorithms. And that then gives us a much smaller font file, and we can then display that in the browser. Okay, and doing your font face to enable a custom font. As I say, we use the same syntax more or less as we used to use that IE proposed way back then. Inside our font face declaration, we declare our font family. In this case, just my font family. And then within the source, we have a URL that points to that particular font file. You'll see here that I'm loading two versions of it. I'm loading the WOF 2 and the WOF. The reason for that has kind of become obsolete. Unless you need to support Internet Explorer, you no longer need the WOF, because all modern browsers support WOF 2. And you just need that. Very importantly, WOF 2 must come before WOF to initiate the correct downloading protocols. And then within your font face, you can also specify your weight and your style. So if we were loading my font, web font /bold, we might say font weight 600 to indicate that for this one, we want a bold. And if we were loading italic, we might change our font style to italic. Okay, so next week we'll go through all of this in more detail, and we'll load up some custom fonts and see how we can work with them. And we'll go through all of that. Okay, so I mentioned earlier that there's still, despite us having worked on this for a long time, and browser makers getting consistency and all of that, we still have some problems with custom fonts, and that has to do with performance. Right, so one of the issues we have is with performance is that the browser needs to load the font before it can display it. And this before, refers to the font loading API in each browser. So before a browser can show a web font, it needs to be downloaded over the network. Even more significantly, a download is only initiated once the browser detects the font family in the CSS file. So you can do your @Fontface declaration and all of that at the top of your style sheet, but the browser will not start the download once it sees that. It will only start the download once it sees the font family declaration. So when you attach that font family to your body or to your headers or to a paragraph or whatever it might be, only then is the font downloaded. So that can cause performance issues. So we need to try and optimize for that. Right, so as I said, this means that web fonts can cause serious performance issues. And what we generally experience are one of two things, depending on how we've set this up. The first one is what we call xheight, or flash of invisible text. So in this case, you might have a page, you hit a page and it starts to load, and all you see is this. In this case, we're seeing some underlines, we're seeing an icon, we're seeing an image, and then if we maybe use the default font, we might see a little bit of text. The rest of our text is hidden until that font download is initiated. And only then, after however long it might be, depending on your connection and all sorts of things we don't really have control over, you then see the custom typeface. So we start with no text, and then we get text. Now, you may note that here we still have a layout, and that's because the browser has still rendered the page, and it has actually rendered the type, but it has changed the color to match the background. Sorry, it's made it transparent. So it's got a opacity of 0. And that then gets swapped out once the font file loads. So we're looking at double performance issues there. We're looking at the file downloading, we're looking at a paint that has to happen again. So our custom fonts can give us serious problems. The other problem we have is what we call flash of unstyled text, or FOUT. And this might be, we load a website and we see our text, it's already there, but the font is downloading in the background, and then it swaps. Okay, and you see now it changes. And this can be quite jarring. You see here, we load a default, in this case, SF text, and then our actual custom font is Avenir. And when we load that, you see the height is going to change because there's different X heights on these two fonts. There's different spacing, there's different descenders, there's different ascenders. So same text, exactly the same, but suddenly it jumps. So these are both not optimal experiences. In the one, you see nothing, and in the other, which is better than seeing nothing, you are still getting that kind of jarring moment where everything swaps out. Okay, so what can we do to alleviate these performance issues? Well, the first thing we can do is just don't use custom fonts. And this isn't a terrible idea. We don't always need custom fonts. In fact, you may have seen around and about something that is called a system font family declaration. And that looks something like this. So On our body, we say font family, and then we say Apple system, and that will use the Apple system font. Blink Mac system font will use an older version of that if you're on an older operating system. Sego UI is for Windows, Roboto is for Android, and then Oxygen Sans, Ubuntu, and Cantarell are for Linux, and Helvetica Neue is for even older versions of Mac machines. And then if none of these are available, then just use the default sans serif font. Now this is if you are happy with this and your design is okay, then this means we've got no performance issues because all of these are already installed on a system. We don't need to worry about downloading them. And the most prominent site I could think of that does this is GitHub. So if you go to GitHub on a Windows machine, excuse the browser stack menu in the bottom left. I had to fire up a Windows machine to take a screenshot. So this is Chrome on Windows, GitHub, that's my profile. And as you can see, the typeface there is using Sego UI. So that is Sego UI, which is the Windows default. If I visit this on my Mac, which I usually use, you'll see the font is going to be different. And as you can see there, now we are using SF Text Pro, which is the Mac default. I'll just go between them. You can see the difference is quite significant, especially if you look at like my profile name there, Justin Slack, in big black letters. You can see that's Windows and that is on Mac. So this is using system fonts to do this. That's one option. Okay, you can say, okay, we're not going to use custom fonts, we're going to use default system fonts, and we don't mind if someone on Windows sees something different to someone on Mac, to someone on an Android device, because those are the devices that they are using most of the time anyway. And you know, there's a reasonable argument to be had there. Right, the next thing we can do is we can minimize downloads. So one thing that our Fontface in CSS allows us to do is look if there's a local version of this font installed. So instead of going straight into our WAF source, we can use the local attribute and then the name of the font locally. So if we are using Open Sans, we can say, well, is Open Sans installed on this user's machine? And if it is, it's not going to bother with the download. So that's another strategy we can use. Look for a local version, and we don't need to download it. We can also download even less. So we can use a lot of tools to remove glyphs from typefaces that we might not need. So we can say, okay, what do I need from this particular font that I'm using? And you can then use some tools to just determine what that Unicode range is. So each glyph in a font, like an O, for example, will have a particular Unicode number attached to it. And you can then figure out what the range is. So here, for example, you can see there, Unicode range U plus 0 to A0. And what that is saying is, show me all the numbers and all the letters. But in this case, with this particular range, this leaves out language support. So if we know we're only ever going to use English, for example, we can set a Unicode range. And that's going to make the download much, much, much smaller. Okay, but this is a bit hit and miss. Yeah, you might end up with that problem I showed earlier with facade, where you're going to lose certain glyphs. Right. One of the best things you can do is download earlier. So I mentioned that your download is only initiated once your CSS file is passed and the browser spots a font family declaration. We can get around this by using a preload. And this goes in the head of our HTML page. And we can use the relationship of preload for this. And then we have an hypertext reference to the name of our font and where it's situated. We say we want to preload it as a font. We say its type is WAP2, and then we very importantly need to say what is its cross origin, so that the server allows this download. I'll go into this in more detail next week as well. Just as an aside, preload is not only for fonts, you can also do it with your CSS and JavaScript to initiate those downloads before, earlier in the process to improve your performance. And then the last thing I just want to go through is, I'm just cognizant of time, is a CSS property called font display. So font display also determines how our fonts load. So it's based on a timer that begins the moment we attempt to use a downloaded font. And we have 3 periods. Again, we'll go through this in more detail next week. And these dictate the rendering behavior of any element using the font. And we have 5 properties we can attach to this, which are auto, block, swap, fallback, or optional. So we just add these as another CSS property to our Fontface display. And what happens is the following. If we say block, we have that invisible, as I showed you earlier, there's no text shown until 3 seconds. If the custom font is still not downloaded, it goes to the fallback. So it would go to the system font, and then it will wait until that is downloaded before it swaps it out. Swap will show you the fallback for as long as it takes for the custom font to download, and then it will swap it out. Fallback says, okay, block for 100 milliseconds, which is really, really slow. I mean, really, really fast. Then show me the fallback and then go to the custom. And optional will block and make it invisible for 100 milliseconds, and then go to whichever one is available. Now, I've gone through that very quickly. It may not be clear at all. There are ways to visualize this, and we'll look at that next week when we start getting into applying a number of these concepts. Right, that's the end of part 1. In part 2, we're going to look at CSS properties for type, and we'll go through all these types of things that we've done. We'll look at loading custom fonts and how we can apply them. We'll look at open type features, which I've mentioned, and then we'll look at a whole lot of new CSS properties that we can apply to type in order to create responsive typography. So this one I know was just me yakking away and talking, but I thought it would be important to get these key concepts down and out of the way. And then next week we can start working on how do we apply them in our actual work and in our code bases. Cool.
Great, thanks, Justin. That was super, super informative.
Great, thanks. Does anyone have any questions? I will make all this material available, obviously, and we also we'll have a recording. But if there's anything I've mentioned that's unclear.
We've got a hands up from Douglas.
I have a question. You said there about the local. Now, is that local on your actual hard drive or local on your browser?
It's on your actual hard drive.
Is that on your actual hard drive? Now, whenever you want them to, whenever does the attribute see if it's on your hard drive first, and then if not, then it falls back to the URL. Is that how it sort of works?
That's right. Yes. It first does that check, and it goes, okay, no, this isn't here. Let's go to the downloadable one.
Okay.
Do you have a question? Oh, okay, not a question, a comment from Tamira. Thanks, I appreciate that.
I also just want to say,
I
want to say, well done for fitting this into an hour, Justin.
Part 1.
Look at you. Yeah, I knew there was some cheat somewhere, some shenanigans.
Right.
I also just want to say thank you, Justin. It was really interesting. Yeah, I look forward to part 2.
Thanks very much. I'm glad you enjoyed it. Right. I'll post materials and everything in the mentoring channel on xheight for everyone. And I've also got a GitHub repo that we'll be working on next week, which you can just download or fork, whichever you prefer or more comfortable with. And we'll be doing some hands-on CSS related to the topics we chatted about, well, related to the topics I have spoken about tonight, this evening. And yeah, I'm on xheight. You know, just ping me if you have any questions anytime. Slack is my real name. It's not my Slack name.
Right, Justin, thanks a lot for the talk. And I think we're all looking forward to next week. And then I guess you will just go and share the video link once it's actually been finished being processed by YouTube.
Yeah, we will handle all of that. And I'll also share the slides and notes and links and all of that in the channel.
Great. Right, everyone. So then we'll catch you next week at 5 o'clock.